400 divided by 5. Inverse tangent, I have 44.6 degrees. Okay, 44.6 degrees anti-clockwise. So the beta angle, right? So this beta angle that we have to determine. So beta will be equal to 120 minus by 44.6, right? So 120 minus by 44.6 is 75.4 degrees. Okay. So what we have got, okay, is we know, okay, we know, bear with me, okay, we know this dimension, or we know this distance, or we know this length. Okay, so this length over here, which is tau max, also correspond to our radius of our circle. We have determined this to be 569.232. Okay, 569 or 569. Or let me write better. 569.232. Right? So we want to locate this point over here, which is our y60. Okay. And then later on, we are going to find out what is the value over here. And this is our x60. Okay, so one side we call it y60, the other end we call it x60. Okay, so now the first thing that I will strongly encourage you all to do is find the shear first. Okay, so the shear, right, of y60 is also equal to the shear of x60, and this is equal to tau max, so 569.232, right? And then it will be sine, and then the angle to use is 75.4, right? So 569.232 times by sine 75.4, you have a shear magnitude of 550.851 megapascal. Okay. So the next thing that we are going to do is we are going to find the normal stress of y60. Okay, so the normal stress of y60 is from where? It's from the stress average. Okay, so we know that this distance from here to here, right? This over here is our stress average, right? So we have to include the stress average for the normal stress. Okay, so we can now calculate stress y60 will be equal to minus 155. Okay, because that is our average stress. Then because it's going towards the right, okay, it's going towards the right of the stress average, so it's going to be plus. And now, right, we know that this will be 569.232 cosine, okay, 75.4. Why I do the shear first? Because the shear I use sine already. When you do the normal stress, it's going to be cosine, right? So you will not make mistake at all. Okay. So what you have is minus 155 plus by 569.232 times by cosine 5.4, 143.486. So this will be equal to minus 155 plus 143.486 is equal to minus 11.514 megapascal. And then the normal stress x60 will be minus 155 minus by 143.486. Y minus, right? Because X60 is on the left-hand side of the average stress. Okay. So from here, minus 155 minus 143.486, the value you get is minus 298.486 mega. Okay. So now the next thing that we're going to do is we have to sketch the element. Okay. And we have to bring it back into the element domain now. Okay. So it's not difficult at all. We've done it before, but we're just going to do it again. So we draw the original first, right? This is our original axis. And then our element is going to rotate what? 60 degrees in a anti-clockwise direction. Okay, so 60 degrees. Where is my protractor? Yeah, 60 degrees anti-clockwise direction. So this is 60 degrees, right? And then I'm going to so we know that this is going to be our, from here, this is going to be our 60 degrees. Okay. Then we're going to sketch the element. Okay. So this is our element. And then we are going to rotate this element by 60 degrees. Yep, there's our element now. Okay. Now you have to be careful now. Okay. So now we are going to label this over here. This is our point Y, right? And then over here, this is going to be our X. Okay. So it's very obvious that this is 60 degrees over here, right? So when that's the case, Y, this is your what? Y60. And this surface over here, okay, this surface over here will be your X60. Okay, will be your X60. So now we look at our Y60. Our Y60 is over here. And the Y60 has a normal stress in compression. Okay, so the normal stress in compression, in fact, both are in compression. So the Y60 in compression, and the value is 11.514 megapascal in compression. And so when you draw your arrow towards the element, I know it's in compression, or we know it's compression. X60 is also in compression, but the value is much higher, right? And then this is 298.486 megapascal. Okay. Then the next thing that we're going to do is we're going to look at the shear, right? So we know that the shear stress is the same for y60 and x60 is equal to 550.851. That's straightforward. Okay. So now over here, y60 will want to generate an element rotation in a what? In a clockwise direction. So y60, we want to generate, so y60, okay, we want to generate an element rotation in clockwise direction. This is the direction of the shear. Okay. And then on x60, so this is x60, right? And this is the rotation, which is anti-clockwise, right? So this is the direction of the shear. So to complete the diagram, right? These are the shear. Okay. And the value we are looking at is equal to 550.851 megapascal. Okay. So in your test, okay, when you are asked to draw this, the important thing to do is to write down the angle, okay, the corresponding stresses, and the direction of the normal stress, and the what? And the shear stress. Okay. So what we have learned so far is now all of you are able to were able to go from element, okay, and then you know from the element you know how to do your Mohr circle, and from your Mohr circle you can bring it back into the what? Into the element, okay, and the element is the real world, right? Like what I draw the element in on the chalk yesterday. This is the analysis, right? So from the analysis, you have to bring it back to the what? To the real world. Okay, so it's important that you can do both ways. Okay, so now, so if you can do all this, okay, you are more or less, yeah, you can comprehend Mohr circle. I will post homework 3 on Monday. Okay, so you can look at Mohr circle. Now, the next thing that we are going to do is we are going to look into 3D Mohr circle now. Okay. Now, 3D Mohr circle uses the understanding of 2D Mohr circle. Okay, the most difficult part in Mohr circle is 2D. When you go 3D, it's not that difficult. Okay, it's not that difficult. Okay, so if we were to now have a transformation now, now in real world, we always use 3D Mohr circle. Okay, 2D is to understand the fundamentals of Mohr circle. In real world, we always construct 3D Mohr circle. Unfortunately, most of the time it has been ignored. Unfortunately. Okay. So now when we have, I draw an element now. Okay. And you all know that over here, this is our stress X, stress Y, and this is our stress Z. Okay. So we also are aware, okay, there are 3 conditions, okay, for 3D Mohr circle. Okay, so the analysis, we're going to analyze, okay, 3 different conditions. So I'm going to write out the condition now. So condition number 1, is where stress X is greater than stress Y, okay, and both are positive. And then we have stress Z is equal to 0. Okay? So this is the first condition. And then in the second condition,